Now let us begin with the topic of statistics. To give a simple definition of statistics, it is nothing but the study of large number of observations. So, in a situation where we have a large number of data points to analyze, say for example, we want to study a population of 1 million people, right? So in that case, it is not practical to study each and every individual observation in isolated manner. So therefore we want to study everything as a whole and derive some meaningful conclusions from it. So statistics gives us the tools to study this large type of data. Alright, now let's go ahead and see which types of data we typically deal with in statistics. So there are two broad types, and actually there are three types as we can see here. The first one is ungrouped or raw data. In the grouped data there are two subtypes, so it can be either a discrete frequency distribution or continuous frequency distribution, right? So let us see the meaning and the example of each of these data types. So we move on to the raw data first. Now by raw data we mean it is just a list of observations, that's it. So as an example, here it's given that the rainfall received for 7 days of some week. So you see here the 7 observations are recorded. So on every day what was the rainfall? There can be unit of course in mm you say. So this is an example of raw data, just a bunch of observations. The other type of data is the discrete frequency distribution, or we can also call it in short as discrete data. So when do we use it? That is, if the number of observations is large, then the raw data is very inconvenient. That's what we can definitely guess. So instead what do we do is the data can be tabulated with the frequency. So as an example, see here we have a table of family size and the number of families. Now here we see the first entry as 2 and 5. So what it means is there are 5 families having the size as 2. Right? Similarly, there are 12 families with size 3 and so on. So rather than writing the values of the family size again and again, since they are repeating, we just club them and write in a compact manner in the way as shown here. So this is the discrete data. Now let's go on to the third type, that is a continuous or the grouped data. So this is class based. That means in this type data is distributed or classified into various classes. Now here also the number of total number of observations is very large, so we have to in some way group it. Now in what way we group it, it's shown in this example. So here the table shows the salary range of employees of some company and the number of employees which have the salary in that particular range. So if you see 0 to 5,000 has 4 employees. So that means there are 4 employees whose salary lies between the range of 0 to 5,000 rupees, and so on with the remaining salary ranges. So this is the continuous data. Now whatever parameters or formulae we are going to study henceforth, we have to keep in mind that they are slightly different from the one type of data to other type. So when we solve any question in statistics, first of all we must recognize which type of data we are given, right? So just to recap, there are 3 types of data: raw data, discrete data and continuous data. Now let's see some of the symbols and terminologies used. XI stands for the ith observation in case of a raw data, whereas in case of continuous data it stands for the class mark, that is a midpoint of the class, and the midpoint can be obtained by simple average of lower and upper limit of the class, right? Then Fi stands for the frequency corresponding to Xi. So for a particular observation Xi, what is the frequency associated with that? That is called as Fi. And lastly, either small n or capital N, it refers to the total number of observations. Let's move on. Okay, now here we go over the important measures of central tendency. Now by measure of central tendency we mean that, as it's written here, it is a value around which the entire data can be considered to have concentrated. So basically, since there are, there can be thousands or millions of observations also, but we must have some parameter which is, kind of representative of that entire data. So such measure is called as measure of central tendency. It's like the entire data has a tendency to, get collected or, present at some central value. That is called as the measure. Now, which measures we consider? So the widely used measures of central tendency are mean and median. Okay, so mean is denoted by symbol x bar and median is denoted by uppercase M. Okay, so now let's go over the mean and median and the formula to calculate those measures for different types of data.